in research exam. So what are decision trees? In simple words, decision trees are tree-like structure which help us in making difficult decisions. Consider a simple case where you have a holiday tomorrow. You're confused as what can be your plan, what you will be doing on that day. You know that you have three choices, but you're confused. You can go for a movie, you can visit your parents, or you can hang out with your friends. Each of the choices is known as decision node, and it has a set of outcomes which is decided on the basis of some rules or logical reasons. So in our case, we choose the suppose you choose the first option, going for a movie. It has two outcomes, yes or no. If you choose yes, you would go for a movie. If no, you won't. Similar is with all the other cases also. Now, to make a decision from this tree, start off from the root node. Root node is the start point of a tree. It has all the values in the data. In our case, it has all the possible choices. So consider the first choice, going for a movie. Now you think for the reasons why you may not go for a movie. Then you realize that you have spent most of your pocket money on other expenses and you won't be able to afford the movie tickets. So you reject the first case. Then you're left with two cases. So you started with three cases. Now you have just two cases to choose from. Consider the second case, visiting the parents. Now you think that if I visit my parents, I'll be able to collect my pocket money as well and will be able to meet them. So it seems a better option than hanging out with your friends. So you reject the third case also and you choose going with visiting your parents. So that's your final decision. This is how the decision tree works. You divide your decision on the basis of the possible choices and then choose the final decision or the outcome. To explain it in programming language, consider the kyphosis dataset. This dataset has 81 columns and 4 rows. It represents the data on children who had corrective spinal surgery. This dataset has 4 columns: kyphosis, age, number, and start. Kyphosis. When we run summary statistics on this data, we get that in 64 observations, the kyphosis value was absent and in 17 it was present. The age statistics show that the minimum value is 1 and maximum is 206. Don't be afraid, this value is in months and it's for children. Number denotes the number of vertebrae involved in the surgery or the number of vertebrae columns on which the surgery had taken place. Start value denotes the number of first vertebra operated on. Now, R has many libraries to call decision trees. We have C 5.0, RPart, etc. To fit a model, we'll use the RPart library. We'll train the model on kyphosis based on the following parameters: age, number, and start. Then now we have a model ready. Now we can plot it. To plot the data, to plot the model, we get this tree. The main objective of plotting is to get the tree and understanding what the tree denotes. So the tree starts from the first case where start is greater than 8.5. Now start is greater than 8.5. It's correct in 62 cases, and this part represents the 62 cases, and this part represents the leftover 19 cases where start is less than 8.5. Out of these 19 cases, in 11 cases kyphosis was present and in 8 it was absent. So this tree on this stage can't go any further, so it stops building here. But on the other value, we have 62 values, so the tree will grow further. Now our model chooses the second logical reason or rule as start greater than or equal to 14.5. This value has 62 observations and it's correct for 29 and it's wrong and it doesn't satisfy for the other values. So out of 29 values where this condition satisfies, all the values had kyphosis absent. Now consider the leftover cases where start was not greater than 14.5. That is 33 cases. Out of 33 cases, we choose age less than 55 months as the parameter. This parameter, this logical reason was true on 12 conditions, and all the 12 conditions kyphosis was absent. Now then we are left with 21 cases. For these 21 cases, our model chose age greater than equal to 111. This logical reason was correct for 14 cases, and out of those 14 cases, just 12 cases the kyphosis was absent, and on 2 cases it was present. And when this model didn't satisfy age greater than or equal to 111 condition, kyphosis was present on 4 values and absent on 3. Now the tree can't grow any further. So this is what exactly a decision tree is. It will start off with your entire data, it will keep on splitting the data and choose a logical reasoning and will operate on it to get the outcome. Now when you say that this start parameter was greater than or equal to 14.5, you see that in that case, when that condition is satisfied along with start greater than or equal to 8.5, you have 29 observations, and you realize that all the observations kyphosis was absent. So you can make future predictions from this. Not future predictions, but you can make predictions when you get a new data. So this is how the decision tree algorithm works. Thank you for watching, and